Hello children, welcome to the mathematics class. Today's topic is permutation, combination and probability. First we start with the synopsis and then we go to the problems. To start with permutations and combination, to start with the first basic concept is about the factorial of n and fundamental principles. If n is a positive integer, then n factorial is nothing but actually the product of n numbers n natural numbers starting from 1 to the number n. So 1 into 2 into 3 and so on up to n. The product is represented as n factorial or factorial n. And in particular 0 factorial is equals to 1, 1 factorial is equals to 1. Next, fundamental principle of counting. One is, if one work is done in m ways, another work can be done in n ways. One work is done in m ways, another work is done in n ways, and then either of the work can be done in m plus n ways. Either of the work can be done in m plus n ways. That is called the fundamental principle of addition. Coming to fundamental principle of multiplication. That is given by, if one work can be performed in n1 ways and another work can be performed in n2 ways, together both the works one after the another one can be performed in n1 into n2 ways. That's called fundamental principle of multiplication. Coming to the next one, permutation. So what is meant by permutation? Each of the different arrangement that can be made by taking some or all the given numbers at a time is called permutation. And the number of permutations of n different things taken are at a time when repetition not allowed. When repetition not allowed. Okay, without repetition, then E is nothing but NPR is equals to n factorial by n minus r factorial, which is nothing but actually n into n minus 1 and so on, n minus r plus 1, n into n minus n, n minus 2 and so on, n minus r plus 1 is nothing but NPR. Of course, specifically when repetition is allowed. Okay, so when repetition allowed, then I say that it is nothing but n to the power of r. NPR is nothing but actually the number of permutations of n different things taken r at a time when repetitions allowed is equals to n to the power of r. And of course, NPN formula n factorial, NP0 is 1, NP1 is equals n, etc. Coming to specific things like restricted permutations. The number of permutations of n different things taken are at a time in which a particular thing includes always is equals to r multiplied by n minus 1 pr minus 1. A particular thing included. Suppose a particular thing never includes, then it is nothing but n minus 1 pr. Together is nothing but npr. So npr is equals to, it is n minus 1 pr plus r multiplied by n minus 1 pr minus 1. This is nothing but a formula to calculate actually npr. These are restricted permutations. Coming to the next one. Okay, permutations of n things in which all of them are not different. Okay, the number of permutations of n things taken all at a time in which p things are alike of one kind, p things are alike of one kind, and q things are alike of second kind, and r things are alike of the third kind, and so on, is given by n factorial by p factorial, q factorial, r factorial. Coming to next one, the number of the number of functions that can be defined from a set containing r elements into the set containing n elements. The first is set A, second is set B. The first set consisting of R elements, second set consisting of N elements. The number of mappings defined from set A to set B is nothing but the number of ways of filling R blank places. First blank, second blank, third blank, R blank places with N distinct objects when repetitions are allowed. That's nothing but N to the power of R. The number of mappings, possible mappings defined from set A to set B. Coming to the number of circular permutations. The circular permutations of n distinct objects taken R at a time is nothing but NPR by R, and taken all at a time it is n minus 1 factorial, and taken R at a time when in one direction is given by NPR by 2R, and taken all at a time in one direction is given by n minus 1 factorial by 2. I repeat once again, the number of circular permutations of n different things taken R at a time is nothing but NPR by R, and in one direction NPR by 2R, and the number of circular permutations of n different things taken all at a time in minus 1 factorial, and in one direction taken all at a time is half the permutations, n minus 1 factorial by 2. And sum of the numbers, the next special formula, it is the number of the sum of the numbers which are formed by n distinct digits excluding 0 is given by sum of all n digits multiplied by n minus 1 factorial multiplied by 111 n times. And of course, as an example, if I take up A, B, C, D are 4 distinct numbers, then sum of all the all the permutations of numbers formed by these 4 taken all at a time is given by A plus B plus C plus D multiply by n minus 1 3 factorial multiply by 1111 4 times 4 ones you have tried. This is n minus 1 factorial 4 ones and 4 numbers. In the same way, if it is 0 included, then it is the formula here. Sum of all n digits multiply by n minus 1 factorial multiply by, it is r times 1 minus n minus 2 factorial multiply by r times 1. Similarly, the sum of all r digit numbers formed by n digits, nothing but sum of all permutations which are formed by n digits taken r at a time, is given by this formula, sum of all the n digits multiplied by n minus 1 pr minus 1 into r1, r times 1s. Similarly, if the sequence includes 0, then this will be the formula. Coming here, the next one, combination. Each selection that can be made by taking some or all of the given things is called a combination. Each selection that can be made by taking some of the things or all the given things is called the combination. And the number of combinations of n different things taken r at a time is given by NCR formula. NCR is equal to n factorial by n minus r factorial into r factorial. And some of the related formulae are given by NCN is equals to 1, NC0 is equals to 1. And NCR is the same as NCN minus r. Of course, NCR formula can also be written as NPR by r factorial, and NCR plus NCR minus 1 is equals to n plus 1 CR. One more identity, you get it. Coming to restricted and two more important formulae which are more important is nothing but NCR by NCR minus 1 is equals to n minus r plus 1 by r, and NCP is equals to NCQ implies either P is equals to R or N is equals to P plus Q. Coming to restricted combinations are some of the important points to remember. The number of ways of arranging R places, number of ways in which R places can be filled by using n distinct objects. Each object may be repeated any number of times is nothing but n power r. Nothing but repetitive permutations. That means number of arrangements of n things taken r at a time when repetitions are allowed is nothing but n power r. Of course, this is a repetition formula. It is a number of n distinct objects around a circle is n minus 1 factorial in one direction divided by 2. Similarly, the other things, this is just a repetition. Coming to restricted the arrangements, the number of ways in which m different objects of one kind and n distinct objects of another kind can be arranged in a row so that no two objects of the first kind together, no two objects of the m things are together is given by arrange the n things in n factorial ways. In the remaining m plus 1 things, you arrange n plus 1 things. M things can be arranged in n plus 1 places in n plus 1 pm ways. And no two objects of the second kind are together is given by m factorial into m plus 1 cn. n plus 1 cn is answered. Coming to the next, restricted combinations. The number of combinations of n distinct objects taken r at a time in which r particular objects are included. When r particular objects are included is given by n minus m. Cr m particular objects are included is given by n minus 1 cr minus m. And if they are not included, n minus m cr is the formula. Of course, this is nothing but actually from the binomial theorem concept, nc0, nc1 and nc2 and so on, ncn equals to 2 power n. The next one is the number of selections of n distinct things taken any number at a time with at least one object selection is given by number of combinations of n distinct things with at least one object selection is n power 2 power n minus 1. This can also be written as number of selections of n things taken at least one is given by, you may select one object, you may select two objects, or you may select three objects, or all the objects you may select it, and that is the same as 2 power n minus 1. Coming to the next one, distribution. The number of ways in which m plus n things can be divided into two groups. One group consisting of m things and another group consisting of n things is given by m plus n factorial divided by n factorial n factorial. m factorial n factorial. In case if m is equals to n, you will be getting m plus n factorial divided by m factorial n factorial will become 2m factorial divided by m factorial whole square, and this is the case when distinction can be made with the groups. When groups are identical, the distinction cannot be done, then you have to divide by 2 factorial. Coming here next, the number of divisors. Suppose if any number represented in this fashion, that is nothing but prime representation, that's nothing but n is equals to 2 to the power of a, 3 power b, 5 power c, 7 power d and so on. This is called prime factorization of n. If n represented as a prime factorization, then you concentrate on the exponents alpha 1, alpha 2, alpha 3 and so on alpha n. Then the number of divisors of that n is given by alpha 1 plus 1 into alpha 2 plus 2 and so on alpha k plus 1, and the sum of those divisors is given by p1 to the power of alpha 1 plus 1 minus 1 by p1 minus 1, p2 to the power of alpha plus alpha 2 plus 1 minus 1 by p2 minus 1 and so on, etc. Coming to the next one about the probability. So far we had seen some of the points in the permutation combination. We start with the probability now. A few points related with the probability. So what exactly? First one, sample space. What is meant by sample space? The set of all possible outcomes of an experiment. Set of all possible outcomes of an experiment is defined to be called the sample space of that particular experiment. Set of all possible outcomes of an experiment is called sample space. And the subset of the sample space is nothing but an event. And an event with one sample point is called a simple event. Simple event or elementary event. So a subset of the sample space with one sample point is called simple event or elementary event, and with no sample points is called the impossible event. And an event which is a subset of the sample space with no sample point is called impossible event, denoted by phi. And the sample space itself is called sure event or certain event. It's called certain event. Coming to the probability definition. So what exactly probability definition? Suppose E is an event of a sample space. Then the probability of that event is defined as the number of sample points in E divided by total number of sample points. Number of sample points in E divided by total number of sample points. So obviously this probability of E is a fractional value, which is a positive fraction. And as the number of sample points in impossible event is 0, probability of probability of impossible event is 0, and probability of the sample space is always is equals to 1. And one or more simple events combination is called the compound event. Coming here, probability of A, if A comma B are any two events, then the probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. This is called actually addition theorem on probability. Addition theorem on probability. And probability of A minus B is equals to probability of A minus probability of A intersection B. And if A represents, if A comma B are mutually exclusive, their intersection probability is equal to 0, because A intersection B is equals to phi. Okay, therefore probability of A union B is equals to P of A plus probability of B. If A dash represents a non-occurrence of the event A, then probability of non-occurrence is equals to 1 minus probability of A. And by De Morgan law, probability of A dash union B dash is equals to probability of A intersection B whole complement. That is nothing but 1 minus probability of A intersection B. In the same lines, that probability of A complement intersection B complement is equals to probability of A union B whole complement. Right? And as a specific examples, two important specific examples. If a coin is tossed n times, then the probability of each sample event is given by 1 by 2 power n. And when a die is rolled n times, its simple event probability is equals to 1 by 2 to the power of, 6 power n. Coming here, the next conditional event, conditional probability. If E1 comma E2 are any two events which are related, the expectation, the occurrence of an event E1 after the occurrence of another event E2 is called conditional event. If E1, E2 are the two events associated with the experiment, then the probability of that particular event E1 when E2 is already occurred is called conditional probability. And the probability of E1 given E2, that is given by probability of E1 given E2 is given by probability of intersection divided by probability of E2. So this is called conditional event. Coming to if the events are independent. What do you mean by independent events? Means that if occurrence of one event does not influence the occurrence or non-occurrence of another event, they are called independent events. That means when the two events are independent, their intersection probability is the product probability. And probability of A complement given B is equals to 1 minus probability of A given B. And if E1, E2 are independent, their complements are also independent. Coming to one more identity, probability of E1 union E2 given E is equals to probability of E1 given E, probability of E2 given E minus probability of intersection given E, where probability of E cannot be equals to 0. Coming here, the Bayes theorem. Suppose if H1, H2, H3 and so on Hn are mutually exclusive and exhaustive events of a sample space of an experiment. If they are mutually exclusive and exhaustive events of an experiment, of a sample space of an experiment, and E is any other event, which is occurring in S, then the probability of E is given by the sigma probability of E given Hi multiplied by probability of Hi is called the theorem on total probability. The occurrence of E is given by probability of E given Hi into probability of Hi, sigma I is equals to 1 to n. And but if Hi represents one particular element, one event in the sample space, given that E has occurred already, then the probability of one of these event Hi with respect to given that E occurred is equals to probability of E given Hi into probability of Hi divided by probability of E. According to the multiplication theorem, this is nothing. Conditional probability of Hi given E is equals to probability of Hi intersection E divided by probability of E. According to multiplication theorem on probability, and that is nothing but probability of Hi into probability of E given Hi divided by probability of E. And that probability of E can be written from here, and that will be replaced. You will be getting this formula, and this is called Bayes theorem. Coming to next one, random variable. What is meant by random variable? A random variable capital X is a function which is defined from sample space to real number set. A random variable X is a mapping defined on the sample space to real number set. It's a real valued function. And the distribution of the random variable is as like this one. If capital X random variable takes the values x1, x2, x1, x2, x3 and so on xn, and the corresponding probabilities are p1, p2, p3 and so on pn, the distribution of x is written it like this one, where sigma pi is always is equals to 1, and that is nothing but sum of all probabilities is equals to 1, and the mean of the random variable is given by sigma xi pi, and that is nothing but expectation of x, and the variance is given by sigma xi square into pi minus mu square. Mu square means it's nothing but mean square, and the variance is nothing but sigma x square minus expectation of x square minus expectation of x whole square. Of course, standard deviation is the square root of variance. We know from the basic formula. The next one is about the binomial distribution. If an experiment consisting of n trials, which are all independent trials, where n is a finite number, with the probability of success is p and failure probability is q, then The probability of R successes is given by NCR into P power R into Q power N minus R. P is called a probability success and Q is equal to 1 minus P. And this is said to be binomial distribution, where the mean of the distribution is equals NP, variance is equals NPQ, and standard deviation is equals to square root of NPQ. Remember that probability of R successes is given by NCR multiplied by P power R into Q power N minus R. Okay, this is about the things, about this few points related with the binomial distribution. And remember that where I say that the binomial distribution with the parameter n and p. N indicates the number of trials, p is called success probability. I say b is called binomial variate with the parameters n comma p. I conclude this synopsis in this video. We continue in the next video with the problems. Thank you.